I'm going to repeat this question. And the first question is, the important part of the question is determine the gradient, with the emphasis on the gradient. They don't ask me for the equation of the line. They only ask me for the gradient. Now what we do is, we're going to work out, we're going to take the given function, we're going to determine the derivative. No? And then once we have the derivative, if we substitute the x value that we are given, what is the given x value? -1. Then I substitute that into the gradient and then I'm going to get my answer. Okay? But now they give you an exercise and they say, consider the graph of g of x is equal to -2x minus 9 plus 5. Determine the equation, underline the equation of the tangent. What did we do in the previous one? In the example, they only asked us for the gradient. But we know that an equation consists out of y is equals to mx plus c. Alright? So what do we want to determine here? What is important? We have a little bit more work to do here. No? So let's go first and by the example determine the gradient at that certain point. Let's go determine the gradient. How do we determine the gradient? The gradient is going to be that value. It's the derivative, no? Gx. So give me the function quickly. Gx is equals to minus 3x cube minus 4x plus 5
It's minus 2, so that look at the root. It's minus 2x squared minus 9x.
minus 2x squared plus
Minus 9x.
minus 9x. Minus 9x
Plus 5.
plus 5. No? And we now want to determine the derivative of this. So we use our derivative rules. We say that is going to be minus 4x minus 9. Alright, yes. Now how do we determine the tangent? Also need the gradient of the tangent. So we want to determine the gradient of the tangent. Why minus 1? Because that is the given point of contact. So in this, we're going to substitute it. Where? On the derivative. Alright, so, and remember what you are determining? You're determining the gradient. So we're going to say g's derivative is equals to -4. What is the point? Minus 1 minus 9. Then I simplify g of -1. Derivative that equals to positive 5 plus 9. It's minus 5 again. No? And what is this that I've worked out? This is my gradient. So that is my in value. So now I want to determine the point of contact. No? So I'm going to use, so this is now how I determine my gradient. So I have my gradient, my in value I have. Now I need to find a point that I can substitute. So I'm going to substitute into the original function here. What can I substitute? -1. Alright, so if I substitute -1 there, I get, what is my answer going to be? Into the, remember, the original function. Because why to the original function? We want the point of contact. So this is now going to be -2, -1 squared minus 9, -1 plus 5. You can type this in the calculator, you don't even need a calculator, that's going to be 1. No? -2. So that's -2 plus 9, which equals to, answer is 1. Alright? So my point of contact is, what is my point of contact? Where x is equals to negative 1 and y is equals to 12. What can I do with that? Is that helpful? Yes. I'm going to substitute it into that because they asked here for an equation. So I'm going to say y is equals to, and what is my e-value? Negative 5x plus c. Now I'm going to substitute, what is my y value? 12 equals to negative 5 times negative 1 plus c. That becomes a positive. I take that positive over, so it's 12 minus 5. So c is equals to 7. Now I have different stuff. I have a gradient, I have a derivative, I have a lot of stuff. Have I answered the question? No. And remember, the examiners, people who are marking your scripts, it's people like me, very stupid. So if they ask you a question in the exam paper, and they see all of this stuff, they don't know what is the answer. Because they see a lot of stuff. Therefore, you need to go say, therefore, the equation of the line is equals to negative 5x plus 7. You end up a question like that. No? I always make the joke with my grade 10 learners or when I'm tutoring, is if you don't answer the question, it's almost like I send you to the mobile, I ask, go buy me a bread, packet of chips and a milk, and you come back and you bought something else. So you didn't follow the instruction. No? You did everything, you went to the shop and you buy your own stuff, but you never followed my instruction. So there's something not right there if you don't follow. Alright, so we're testing the comprehension. I give you instruction, can you follow instruction? And that's basically what it is. Okay? Just to point some light on that. Let's turn the page there. Everyone is clear with that example?
Yes.
Okay? Let's turn the page there. There's different types of questions that go there. There's a standard form where we know our function, that d value is my what? Y-intercept, great stuff. Alright? Then I have my turning point form, and then I have my intercept form. You know that if a is positive, where I have a function going upwards, and then when a is negative, we'll go have a function being decreasing. And there's your different stuff to determine your derivative and your point of inflection. It's your second derivative. Then your concavity is also based on your second derivatives equals or greater than 0. Okay? Let's do the questions now of that one. Let's do that together. And then we're going to see how far we get with this. Alright, let's do the first question together. I don't know. The register?
All signed, right?
Yes.
Thank you so much.
Okay, so I'm going to give you a few minutes to look